Alright, in this video I'm going to go over lesson 7.6, which is in your purple books. So if you have those at home, hopefully you do, go ahead and get those out and turn to that page. I'm not sure what page it is, but again, it's lesson 6, unit 7. What we're going to talk about in this lesson is basically factoring. We're going to factor over the next couple weeks. If you would, I want you to look at 6.1 where it says puzzles of rectangles. We're not going to do that. I want you to look at 6.2 where it says using diagrams to understand equivalent expressions. Okay. It says use a diagram to show that each pair of expressions is equivalent. Okay. You can use a diagram if you want really quickly. I'm just going to use the distributive property to show a few of these. That first example is x times x plus 3. This is in factored form. If I want to go to standard form, we would distribute the x on the outside of both terms inside of the parentheses. X times x is x squared, and x times 3 is 3x. I'll do one more example of those. Go ahead and find this example if you would. Again, this is factored. If I want to go to standard, I'm going to distribute. X times x is x squared. X times 4 is plus 4x. 2 times x is plus 2x. And 2 times 4 is plus 8. Sorry if you can't see that. Simplified, that is x squared plus 6x plus 8. So again, just two basic examples of going from factored to standard. That is nothing new. Today, we're going to do the opposite. With factored, you're going to go from standard to factored. And you're like, well, that shouldn't be too hard. It's going backwards. It is a little bit more difficult because you have to deal with your number sense. So if you would, I want you to go to 6.3, where it says, let's rewrite some expressions. And what I want to look at mostly is the right side column, the standard form column. And I want you to look at the first expression in there. If I wanted to convert x squared plus 9x from standard form to factored form, notice first off that we have the square term and the linear term. We don't have the constant term, which is just the number. What I can do is I can pull out an x. And if you notice, both of these pieces have an x in them. So I can rewrite this as x times whatever I get when I divide by x, technically. We don't want to write divide by x, because if I plug in a 0 for x at any point, then I'm breaking our biggest algebra rule, which is dividing by 0. But this is technically what we're doing. X squared over x is x. 9x over x is plus 9. Okay? We went from standard form to factored form, and that would be my final answer. Okay? Same way with the one below it. If I have x squared minus 8x, I can pull out an x from both of those terms. X squared over x is x. 8x over x is 8, and we have a minus in the middle because we have a minus right there. Okay? So two basic examples. That's not super new. What I'm going to show you next is new. Please look at the problem that says x squared plus 13x plus 12. Okay. Your job or your directions are to factor. The difference between the first two problems we just did and this one is this number right here. There's a constant on the end. That changes things. I can pull out an x from this piece and this piece, but I cannot from this piece because there's no x there. So our strategy has to change because of that. And this is what our strategy is going to be. We're going to find two numbers that multiply to give us 12, but also add to give us 13. So what that requires us to do is write the factors of 12. I'm going to do that down here. 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. And, oh, that was all of them. I want you to look at those three pairs of numbers and tell me which ones add up to be 13. Hopefully you saw that it's 1 and 12. 1 plus 12 is 13. So when I go to write this factorization, I take those numbers, x plus 1 times x plus 12. And that's it. Well, how do I check it? Let's distribute x times x squared. X times 12, 12x. 1 times x, just x, and then 1 times 12 is 12. When I add those two together, I get 13x. And so I get x squared plus 13x plus 12. And because that is our original problem, we did this correctly. Okay, that is your general process for factoring when you have three terms and there is a 1 in front of the x squared. Okay. One second. Okay. Let's do one more together. And I want to let you try a few. This one should be right below the first one, or the last one we just did. Same process. There is a 1 in front of the x squared. I have three terms. I'm going to find the two numbers that multiply to give us 12, but add to give us -7. That kind of changes things a little bit. I want you to start off by continuing to write the factors of 12. 1 and 12. And again, the term factors means numbers that are part of a multiplication problem. Well, none of those add up to be 7. 3 plus, we have -7 there, but all of these add up to be positive numbers. Well, let's make one of them negative. Let's start with 3 and 4. -3 times 4 is -12. I need those to multiply to be positive 12. If we make them both negative, -3 times -4 is positive 12, and those also add to be -7, so this one works. What I'm saying is, on problems like this, you have to be careful with your signs when there's a minus right there. So I have x minus 3 times x minus 4, and that is that. That is the factored version of this standard form problem. Okay. Really quick, I want you to pause after I show these. I want you to pause the video, and I want you to try to factor these three. Okay, go ahead and pause the video. Try to factor these three problems. If you can't see this bottom one, I'll show it. after you're done working the problems. Okay. Here I have 3 and 3. That gives me x plus 3 times x plus 3, which can be rewritten as x plus 3 all squared. That is the first one. Secondly, 1 and 9. Now I know I'm not writing down every factor pair. If you want to do that, that's fine. I'm just going to, for a second, write the ones that actually. I get x plus 1 times x plus 9. And then for this third one, notice we had a positive 10 here. Now we have a negative 10. That will change our strategy just a little bit. I still have 1 and 9. But again, my sum is negative. I need to make both of these negative to make this work. So I have x minus 1 times x minus 9. And we've got it. Okay. So guys, that's basically it. That is basic factoring of trinomials. I'll have a homework assignment posted pretty soon. I'm going to send out an email so you can see what you need to be doing. But this is the video you need to watch to kind of get the general idea. If you have any questions, feel free to email me.